Alright, time for another draft. Physics.com, debatephysics.com also. But the debate is so ugly and disturbing and nasty and it's just so bad that there's almost no point. But there's no alternative. This is all there is. The internet, this dirty, stinking, rotten medium with which to communicate with other humans and try to elevate the standard of communication. But you know, it's just hard not to go low because that's all they do is go low. So I will rise above it, all right, and try to stay on the subject. I'll just note that he's now also made a Quora post, so he's used his account at Quora to again verify his slander, which is really so fucking dumb. But anyway, we'll see. Anyway, so the arguments, we knew what was going to happen. There's another air track experiment demonstrating this free momentum thing. Again, we'll go back to the pendulum argument to make some of these points, but I mean, it has a consequence, and I'm just saying if people are going to say there's free momentum, it has a consequence. So in the best example is the 3-to-1, because you end up with the same velocity going both ways. So the two things that the momentum that you're creating stays in the system and it comes back. And when it comes back, their argument is that somehow the energy actually cancels. So the free momentum disappears. So that somehow you could actually have a car crash where you have a car that has 150, we'll just say, or 1,500 momentum, and it can crash into another car with 50 momentum, 500 momentum. And somehow you're not going to get a collision of 200. You're just going to get 100 popping out. One car will go 100 and that's it. That's all. I mean 100, I mean 1,000. Sorry, momentum. So, I mean, it doesn't make any sense. So you know that if I put something crushable, a little box, all right, so I have the one mass comes in with 100, hits the three mass, they both fly out, and now they're going to come back together, and I just put a little box in there. You know the box, I mean, this experiment's been done, Mythbusters, different people. The box is going to feel the crush of both of these things together, and the crushing force on the box, or the spring, I mean, it could be just a spring, is going to be 200. Okay, no doubt about it. So it's not going to be, the energy is not going to disappear. The momentum is going to do work on the box or on the spring. It's going to do work. It's going to change it based on how much force, compression force was applied, and those changes are measurable. And, so they're arguing basically that it has these joules of energy, heat. It's going to create heat here. It's going to create heat, and, compressing the spring, releasing the spring would create heat. So if I threw a compressed spring in a joule tank and let it release, its energy will be felt in an increase in the temperature. So the 200 is there. And this argument somehow, if I don't put anything in between and they crash together, so two cars with bumpers on them, very springy bumpers, that somehow 200 momentum comes in and only 100 momentum pops out. I'm just saying that's got to be a little bit, it's got to make you a little uneasy to say, oh yeah, I'm sure that's the way it works. I mean, it's got to sound wrong to you, right? I mean, I'm trying to be fair. I mean, you're saying it doesn't seem wrong to you that I can have the momentum, I know it's there because I can collect it, and then the momentum somehow, if I make the collision bouncy, that somehow I'm not going to get the same output. I'm not going to get the same joules of energy. This one thing moving at 100 is not going to heat a joule tank the same amount. And I'm not going to have any heat in the objects because we know, unless you force them together, if they're free to move, they'll move instead of getting hot. So that's not going to be the answer. So there's just no way to really explain, how you can take 200 in and get 100 out. That's not conservation of momentum. That's a collision that wouldn't make any sense. Now, I'd argue that all those people that study car crashes would never say that the energy cancels. You know, that they could have something go in with 80 and something go in with 70, and they could cancel the 70 and only have 10 left over, and 10 would fly out. So, I mean, you can take this to an extreme. That is, if I take it and make it a 1 to 20 mass, then it's 90%. So that means 190 goes up and 90 goes this way. So then you have 190 against 90, and you're going to argue that only 100 pops out? I mean, you have 280, right? It's a lot. 280 in, only 100 out. That's the take it to its logical conclusion. That's where the theory or the statement goes to. And I'm just saying, you can't recognize how there's reason to doubt experiments that say that happens, because it doesn't really make a lot of sense. Now, my argument in this case is that there's only 75 the momentum going this way, and only 25 this way. Obviously, 75 hitting 25, the total is 100, so it makes perfectly good sense that that's what you get out. So I've already pointed out, too, how you could just change the experiment by, making the 3 mass not on a pendulum, just have the 1 mass fly off and keep hitting it. So if I take a 20 mass and I put it on a little, just a tiny little elevation where each ball just knocks out, the next one falls in, and that's knocked out, the next one falls in, I can keep making, I can get 90% of the momentum going that way and that way. So I get 90% back, and I get 90% going that way. So I get, 180 going this way, and I get 90. I get 190 going this way and 90 back this way. And then it can hit again, and now it's a little less because it's only 90 and not the first 100 I put in. But you can just get the idea that 180, 160, 130, 110, it's going to add up to an awful lot of balls rolling with momentum. And it seems very unrealistic, I think, for you to argue that if that actually happens, that nobody's clever enough to collect the 5 or 6 or 700 momentums created by just one momentum in, and that somehow they can't regenerate the experiment out of that 700 of momentum. You really think so? You think you can't hit the lever with the 700 and get 100 coming out again? Yeah, I think you could. Anyway, so I have pointed out that this air track experiment has some defects, and I pointed out that they put the bumpers up here. Big mistake. They don't make them regular elastic. That is, they're made out of metal already. So why not do the experiment without any rubber bands, without any springs? Just let the metal cart hit the metal cart. I mean, that should work. There's no law that says everything will fall to pieces and nothing will happen and it won't work and it'll be hugely inefficient. Nothing says that, and I've never, in every single trial I've ever seen of this experiment on an air track, I've never seen it attempted without a spring. Making it a super elastic experiment rather than regular elastic. So right there you should be able to agree that, okay, that's not much to ask for, right? That's a pretty minor thing for me to say, well, why not do it with just metal against metal? What's the big deal? That can't take too much work. And obviously in like Professor Lewin's case, the springs were on the center of mass. And so that's, I think, why he had to put clay on the carts, is because he wasn't tipping the carts. His air track wasn't lifting the carts up by hitting at the high point. And again, everybody should be able to realize if I made two objects that were going to hit each other and let them hit way up here, way above their center of mass, that there's every single likelihood they're going to do that. When they hit, they're going to tilt. Just logic says so. Because it's a rotational momentum being imposed. It's not going through the center of the mass, So it's going to force the object to rotate, try to rotate. So again, these are, if I think you could be possibly fair, you'd concede, yeah, these are reasonable questions. Why not do the experiment? Why not change this a little tiny bit? Put the contact point lower. That's not a very big deal. Make the contact point just metal instead of springs and rubber bands. Not a big deal. And then they could even do the experiment, where they actually turned into a pendulum experiment. That is, just allow the carts to go to the end and bounce back. So if they position this in the right location, in the case of his 1 to 1.5, we're talking about everything in fifths. This gets 1/5 of the velocity, and this gets 4/5 of the velocity. So you just know that you make this distance 4/5, and you make this distance 1/5, proportional to those ratios. And so this slower thing will go a shorter distance and come back. This one will go the longer distance faster and come back, and they'll hit right here in the middle again. And now you'll have an experiment where you're hitting 120 into 20, and you can see if the 120 into 20 just makes 100 come out. So that's a fair experiment, isn't it? So is that, again, asking too much? Oh, we have to modify the experiment a little tiny bit. We experiment with it a little bit. We change the rules a little bit. So I've also suggested that, we could get the big giant ratio of 1 to 20, by merely using a pendulum, to hit a small mass into the cart. So you could just take a regular Newton's cradle, just take one of the balls, give it a little bit of elevation, let it hit the first cart, and see what kind of velocity you get from the height of that pendulum, the velocity of the pendulum. Now, that might be a little tricky measuring the velocity of the pendulum, but I'm just saying it's, at least it's something you can do. It's not undoable, it's doable. And now you'll be getting this huge amount of momentum increase, where you're getting 80 or 90% more momentum in the, you put 100 in, you get 190 out. That's a huge amount of extra momentum, and you should be able to measure that, to really prove this thing. It's like, again, they say it takes 4 times the energy to go twice as fast. Well, that's an experiment you can rig, but you really can't rig the, 3 times the velocity taking 9 times the energy, or producing 9 times the impact damage, and then 4 times the velocity creating 16 times the energy, the spring compression. I mean, 4 times the velocity is not going to compress a spring 16 times the amount, and certainly 5 times those. So those experiments are the ones we never see. They're not anywhere in the catalog of experiments we can go view, and those are the ones that are really going to prove the case, right? I mean, if you're going to make this argument that this thing happens, this quadratic increase, wouldn't it be best or fair for somebody to argue that, well, at least show me the 9 times the fuel to go 3 times as fast. At least show me that one. All right? I mean, you could, that doesn't seem like that's asking too much. Come on. Show me the car crash. 10 miles an hour and 30 miles an hour. And show me how the 30 mile an hour crash is 9 times more damage to the car. Right? Is that asking too much? I don't think it's asking too much. I don't think it's asking anything at all. I think the science should have already done it. Out of their own curiosity, they should have done it. So, we'll see, right? There's nothing else. I don't have an air track. I can't play with it in my subsidized school laboratory. I can't do, I don't have the equipment. I can't do it. They're the ones that have the equipment. Let's see, are they willing to modify the experiment a little bit to see if they can make it a little more fair? I mean, any physicist should know that they really should. Ideally, they want the contact to be through the center of mass, right? There's no, the logic of not having the contact point going through the center of mass, I mean, that's elementary physics. I shouldn't have to explain how, that's really the ideal. You really don't want to do it this way. And to explain that springs aren't just perfectly elastic, in the first sense, they don't store energy perfectly, And in the second sense, they're not elastic like hard objects. They actually slow an interaction down. The compression of the rubber band is absorbing time and compressing an elastic object, something squishable. And things can be, have a high constant, like a strong spring, or a weak spring. A weak spring takes more time to compress, a strong spring less time to compress. So you could also understand that might have an awful lot to do with this. That if you use a hard spring, you're going to get a very different result than if you use a soft spring, because you're slowing the collision down, storing more energy in the elastic object, and the elastic object's going to equally spread it back. So it goes in one way. The spring compresses one way from the energy this way more, and yet when it gives it back equally in both directions. So that's another fact. I shouldn't have to explain to physicists. So, I'm saying, you're saying I'm being unfair, that I'm nitpicking, that I'm just desperate to say that the experiments aren't any good because they don't match my results, blah, 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 blah. Well, I'm arguing that I have good reason to doubt your theory. I mean, once again, do I really have to write it down? Your theory says 25 times the force to get 5 times the velocity. I mean, that's an extraordinary statement on its face that we never see in reality. I mean, everybody who's used equipment, heaters, drills, chainsaw, all kinds of electric devices know, I can pull on that trigger and I'm not going to use a ton more electricity. It doesn't, the machines don't work better, more. I don't save millions of dollars, by running the thing barely spinning. None of that happens. So this is a bold statement, bold. And you don't think you have any obligation whatsoever to show me that. To show me any indication. And again, when the Mythbusters did the car crashes, I mean, come on. It was pretty glaring evidence, okay? Same car. 100 miles an hour, 50 miles an hour, right? Okay. 100 mile an hour car only crushes twice as much. Not 4 times as much. Not 3 times as much. Not 2.7 times as much. Not 2.5 times as much. Just twice as much. And when they did the same experiment with clay, the results were the same. Okay. No indication of 4 times the amount of clay displaced. So, there are good reasons to say, all right, you can claim this stuff, that you can make this free momentum stuff, but you really should be able to back it up. And again, the idea of, there's 2 points. There's this kinetic energy, 1/2 mv squared nonsense, and then there's this idea that somehow if I make energy, that somehow it can cancel. So again, I provided these examples over and over, but there's just no point in talking to you people, right? I mean, I put 2 cue balls here and I hit them, 2 pool balls, and there's not enough space, and this one's going to hit both of them, okay, at pretty much the same time. It's going to lose, let's just say, 90% of its momentum, and these 2 balls are going to leave. Now the fact is they have vectors in opposite directions, right? That's obvious. Those vectors don't cancel. So yeah, they're not perfectly opposite, but they have a vector, they have a component in the opposite direction. And the fact is, I've never heard anyone ever say that, oh yeah, I've increased the momentum. This vector, okay, when I add up these 2 vectors, their magnitude, somehow they can be more than what I started with. And they can't. There has to be the same MV here and here. When I add up these 2 MVs, they have to add up to this MV plus whatever I had left over. And there's no cancellation. Nuclear bombs don't create no momentum. Nothing, this idea of a cancellation, how can it make sense? Especially when I can just change the direction anytime I want. I just put a rubber band in this experiment and both the carts are moving in the same direction. So I put 100 momentums in this way, I can get 100 momentums coming back. I can get 150 going this way, or I can just let this bounce off of something go, then I can have 150 going this way, and I can get 150 going that way. 100 in, 150 out. Or in the case of the, 1 to 3, I can get, 100 in and 200 out. All right, that's got to be enough. So I'm just saying, fine. He did an experiment, okay? I can't argue that there wasn't any clay on it, okay? But, this is the difference. These experiments are all done subtly different. The carts are different, the tracks are different, and there's different variables you can fiddle with. And obviously, I guess, I'm just saying it's a pretty glaring variable that a big difference between his experiment and Lewin's. Well, first, he doesn't have a bigger cart. He has putting more weight on the same size cart, which is also, obviously, it's sinking more in the air. So who knows what that even leads to. He's making the cart 50% heavier. So obviously it's the same size profile. So obviously it's got to be sinking in the air lower. So that's not ideal. And so the Lewin cart was twice as long, which is obviously probably the better configuration. And, because then you have the same lifting height, the same amount of air flowing underneath the cart, all those kind of factors. But clearly, the Lewin cart did have the bumpers much closer to the center of mass, and his experiment, obviously the bumpers are way above the center of mass. Those are suspicious circumstances. And I'm just saying there's lots of experiments you can do to prove those things don't matter. And they haven't done any of those experiments. Again, they can't even just push the cart and let it bounce back and forth. Somehow that doesn't, they won't even do that experiment, and see if it gains any velocity. All right. So, yeah, that's enough of a video. I have to find my mouse. So, that's my response to his video, is that I've already argued all these points over and over why I'm unconvinced. So if you're going to claim this happens, I'm saying until you make some argument that makes sense that a car crash can create variable amounts of momentum out. That is, if I was to do it in a Joule tank, I'm going to get an answer, right? If I drop a 1 mass going 50 and a 3 mass going 150 into a Joule tank, it's going to measure 200. And you're saying that somehow, okay, if I just have the interaction happen above the Joule tank and only 100 goes in, that, somehow I've destroyed the momentum. The 200 momentum is gone somewhere. And again, to argue that it's somehow created all that energy as heat when you haven't even tried to measure it. I mean, again, they've had infrared cameras for how long? Do a Newton's cradle. Do the experiment and film it. See if it gets any hotter. See how hot it gets. Yeah. Because where else can it go? There's nowhere else for this energy to disappear to, this momentum. You can't make momentum disappear. And you're arguing that you can, and you're insulting me because I'm not stupid enough to say, oh yeah, that makes sense, because it doesn't make any sense. In one configuration it can't be 100 joules, and in the other configuration it be 200 joules. You can't get those two different answers. You can't have the same spring compression and push two 100 mass carts and get a number, and then push two 200 mass carts and get a completely different number. That means your fuel changed. Somehow the fuel knew that, it's not supposed to make as much energy. I mean, it doesn't make any sense. And then all the other arguments. I mean, geez, the ballistic pendulum being incapable of collecting this kinetic energy. Water hoses, incapable. Gears. every single mechanical test you put this to, you can't collect any of this stuff. The simplest mechanism in the world, to put a thing in space and have it shoot a mass off of its surface. The kinetic energy of what you put into space, won't equal the energy you get. The kinetic energy won't produce work. Fact. Alright, yeah, that's enough. Alright. So anyway, the whole thing has gotten just way out of hand. Two physicists, and they're just so opposite personalities. And one of them is this little wishy-washy Mr. Rogers guy who doesn't want to deal with anything too serious or real. And this other guy, well, he's all his physics is woo, right? So all his papers are a bunch of convoluted quantum crap. It's not even quantum. I don't even know how to describe it. It's so way abstract, mathematical shit. And then this silly Einstein cat thing that's not even an experiment. I mean, it's not even a thought experiment, frankly. It's just so stupid. It's like saying, if I drop this weight, we kill a cat. If I don't drop the weight because, you put an itchy thing on my hand, then the cat lives. I mean, it's just, there's no reason for the cat in the story. It's just too stupid. It's too stupid. Somehow you've proven time dilation, but you sent something away. The atomic clock and the regular clock sitting at home don't agree. Therefore, you kill a cat. I mean, there's nothing to this experiment. It's a gratuitous use of the cat for no purpose. It has nothing to say about this experiment. It's just a toy he's abusing. It's just amazing garbage. And it's actually on I couldn't believe, people link to the Wikipedia page, and right at the bottom is his silly little, paragraph. So I'll read that just because it's ridiculous. It means nothing to the subject of relativity. It proves absolutely nothing. It makes no contribution to any of the elemental arguments. And again, the elemental argument is do you think photons move crooked paths? They can have two momentums. They can go this way and they can go that way. Do you think photons can do that? And if I move a target, somebody's shooting an arrow, and I move the target, does that mean the arrow moved? I mean, do you know that the arrow went straight, right? It went straight. Moving the target doesn't make the arrow go crooked. I mean, it's that simple an argument. I mean, how can you people fall for this crap that somehow the arrow knows to move because I moved the target? Or that the arrow when the arrow doesn't move, that somehow it did move it took a longer path to move exactly the same straight line. I mean, I don't know how you even make sense of the crap. It's so bad. Yeah, so anyway, the ball hasn't been advanced any here, and we need somebody who will do these tinkering experiments. Somebody who will tinker with these experiments. Try to do the 1 to 20 thing, which he can do on the air track. Like I say, he can take a little tiny impulse and hit the air track cart and see if he can make twice the momentum go into that cart. Because that's what their theory says you can do. Alright, anyway. So, till the next time. Well, almost. And such, and so forth and whatnot. Just very disturbing, depressing, irritating. But what else is new, right? Nothing new there. Well, I mean, the very fact that if I actually have to sue this fucker, I really don't want to get into all that legal crap again. But, I can do it. That's what's required. I mean, there might be a benefit to it, actually. It might be good publicity in some way. Who knows? So maybe I can make some reasoning to say, it's going to be worth the time you have to waste. But anyway, we'll see. So, till the next time, and such. I just don't see. He's such a child. I don't see him conceding he was totally out of line and making an apology. And he really has to do that. He really has to.